Okay, so we're now going to cover the last part of the chapter, which is 1310, and this chapter is dilution calculations. Dilution calculations. We are on page 592. Okay, so what is a dilution, guys? So the very easy way to explain it, and I'm gonna draw as best as I can, of course, but I will be able to convey you guys the concepts here. So the formula that you can see in the textbook on page 592 says the following: if you want to dilute something that is more concentrated, it's called stock solution. M1 V1 is equal to M2 times V2, and usually you put stock solution as the initial solution, and the stock solution is the more concentrated solution. In our case, has higher molarity, more concentrated solution. And the diluted solution, now this is a diluted solution, is now less concentrated. So in the lab, concentrated. In the lab, sometimes you have a hydrochloric acid, concentrated solution is 12 molar, let's say, and you want to prepare, let's say, 3 molar concentrated solution now, for whatever the purpose. So you want to be able to do it using a solid equation, something that you can rely on. So now, but what does it mean? Why this equation works? Why does it work? Because in the reality, what happens here is that if you break down this equation, you will have N1 over V1 times V1. So this will cancel, is equal to N2 over V2. So what I'm using here for molarity is the formula that we learned in the previous videos, times V2 cancel. So in other words, what you're stating here is N1 is equal to N2. So number of moles of the initial solution is equal to the number of moles of the final solution when you dilute a solution from a stock solution. But how does it work? I mean, why this is correct? Now, to prove that, let's say we have a bottle. We have a bottle of the concentrated HCl. We got this bottle here, and this concentrated HCl is 12 molar solution HCl. And let's say we have this volumetric flask, which is exactly 100 ml. There's a line here. So this is 100 ml volumetric flask. You probably guys see this volumetric, should be no R in here, volumetric flask. You guys probably see this one, already have seen in the lab when you guys had face-to-face lab meetings. And so I want to prepare, let's say here, 3.00 molar solution here. And here I'm starting with the 12.00, let's say, molar HCl. I just want to have, well, we don't have to have so many significant figures. Let's say 3 here, 3 here. And so how would I do it? So I'm going to use this formula right now, and I'll show you how number of moles in here will be equal to number of moles in here as we transfer these number of moles. Okay, so I know that my M1, which is 12.0 molar solution right here, 12. This is M1. This is the concentration of my first solution, my stock solution, times, I don't know how much I need to take out to prepare this solution. I'm going to put it V1. Could have been an X, doesn't matter. But I just want to be consistent with the terms here in this equation. So now M2 here, I know what I want. I want 3.00 molar solution. And I know the volume I need to get here. Let me just put it right here. I need the volume. I need to make 100 ml times 100.0 ml. So now it doesn't matter here whether you use ml or liters. In the dilution formula, it doesn't matter. In the molarity formula, it does matter. You always, guys, use the liters. Now, how do you find V1? V1, just cross multiplication, will be 3.00 molar times 100.0 ml, then divided by 12.0 molar. Molar cancels out, and so now we know the volume we need to pipette. Let me do the calculations. So that will be 3 times 100 divided by 12. I think it should be 25. Yeah, exactly. So that will be 25.0 ml of HCl. Let me just be specific here. Will be 25.0 ml of 12 molar HCl. Okay, so how would I prepare this? I would, let me just erase this a little here. I need some space here. You guys already copied everything. You can always rewind the video and just go to the clip that was, I guess, recorded before. Now, so what I'm going to do now is I'm going to use a volumetric pipette. I'm going to insert this volumetric pipette. It has a certain shape, this volumetric pipette. Okay. So I'm going to insert this volumetric pipette here inside. And of course, I usually have a bulb in here I need to aspirate the liquid with. And so what I'm going to do, there's a line here, 25 indicating. What I'm going to do here, guys, very important. I'm going to aspirate the liquid in. And I'm going to aspirate the liquid in. I'm going to have a certain number of moles of my substance in here, certain number of molecules in here of my substance, of HCl in this case. Okay? So I'm going to take it out. I'm going to take it out now. Take it out. I need 3.00 molar. I'm going to take it out. This amount, fixed amount, I'm going to take it out. I'm going to take out this number of moles. There it is. It's in the pipette right now. And I'm going to transfer this fixed number of moles in here. Fixed number of moles into the receiving vessel here. So this is my burette, same burette. Okay? I mean, not burette, I'm sorry. Same volumetric pipette. Okay, so there it is. So what I'm going to do now is I'm going to my pump in here. And so I'm going to transfer now these so many number of moles, same number of moles. You see, this is my N2 now. N2. So N1 is the same thing as N2. Same number of molecules, same number of moles. I'm going to transfer it here. Now, all of these that used to be in this pipette in here, they're going to be in here. And my next step will be, once I got these number of moles, now in my volumetric flask of the concentrated, I will add now, this is it, let's say my 25.0 ml. I'm going to now add, this is a line, H2O into here until the bottom of the meniscus now will be touching this line. I'm going to put the stopper here. And then I'm going to mix it. So this now solution will contain 3.00 molar HCl. Again, guys, all I did, I used this formula here. And I explained you why this side is equal to this side. Because if you now break it up, you will, the molarity, you will figure it out that you will see that you're going to have number of moles on this side and number of moles on this side for two conditions. But when you actually understand the process, how you prepare the solution, you will understand that once you aspirate the stock solution inside of this pipette and bring whatever the number of moles in here, which is N1, into here, as you're bringing these number of moles in this fixed volume, as long as you don't lose anything during the transfer, you still got the same N1 in here. N1 is equal to N2 in here. And so you're going to now deliver the liquid, the solution here of HCl. And then, of course, here you're going to add more water now to dilute it to get 100 ml total solution now of 3. And the resulted now molarity will be 3.00 molar HCl.